our final topic in permutations. Let's think about this example. How many permutations have the property that, for all j greater than 1, there exists I less than j, such that wi equals wj plus or minus 1? When we're approaching this problem, the first thing to do is to take any permutation you can think of and just do it as an example to see what the heck this means. So let's take the example that we had before. That was a pretty good permutation. I'm going to write it in one line notation. The permutation we had before was 1, 5, 1, 3, 6, 2, 4. Okay, this is a perfectly good permutation, and let's check what this property says. It says, for any j bigger than 1, okay, so that means that I'm looking, and it's going to be about a wj, so the j thing. So this is w1, w2, w3, w4, w5, and w6. Okay, that should help. So this condition is that for any j I pick that's at least 1, so if I'm looking at these guys, so let's just take w5, okay? If I look at w5, this is going to be the case that j equals 5, okay? There needs to be an I less than j, so something to its left, such that wi is wj plus or minus 1. That means I look to the left and I want to see the number 1 or 3. Well, in fact, I see them both, so okay, good. We're solid for the number 2. What about for another number? So let's take 3. This is the case where j equals 3. And I'm looking to the left and I want to see either 2 or 4. So I look. No. I don't see to the left. I don't see the number 2 or 4. So this permutation fails the property. Okay, let's do another example. And here, the number 1 also failed the property. So let me just switch this example a little bit. Let's take the permutation 5, 4, 3, 6, 2, 1. Let's go through and systematically check, does this permutation have this property? So what we do is we take the number 4 and we look to its left and we either try to find 3 or 5. I have found the number 5, so I'm happy. That one works. Now we take the number 3. We look to its left and we're looking for either 2 or 4. I found the number 4, so I'm happy. Take the number 6. We look to its left. Now 6 is interesting because 6 is really big. There is no 7, right? So I have to find the number 5, and luckily I do. Right there. Okay, found the number 5. What about the number 2? I look to the left and I'm trying to find either 1 or 3. Got it. The last number is actually pretty easy to do because the last number, everything's to its left, so it's no problem here, but we can, for example, find the number 2. But notice that because this number is 1, 2 is the only thing I could have found because there is no 0. But in any event, this guy checks out. This has the property. Great. So the first thing you do when you have a problem like this is to just do some examples. Okay, see if you can get some intuition for what works and what doesn't work. Maybe why something works and why something doesn't work. Another approach that you can do after you've done some examples is you can try to do a lot of examples. But what I mean by that is not just pick some random things, but let's be systematic about it. So here I've listed all permutations of 3. And it's good to have a list of this. In fact, for your homework, I've asked you to list all permutations of 4. And I recommend that you keep that handy for most of your homework problems for this week. Okay, so once you have your permutations of 4, I'm just going to do 3. I have them written in one line notation, and I have them written in canonical cycle notation. When I have a problem, I'm not sure at the outset which notation is going to be better. Given the way this property goes, this property is really about one line notation, so this is really what's more interesting to me. But it's sometimes handy to have both notations side by side, just in case. Let's check these guys and see which of these has the property and which doesn't, okay? So again, we don't check the first guy because there's nothing to its left. And similarly, there's no point in checking the last letter because everything is to its left, so it'll have to satisfy that property. So really what's important here is what's the middle letter. That's the only thing we have to check. Okay, so for 2, I look to its left and I need to see 1 or 3, and I do. So this guy is good. 3, I look to its left, I need to see 2 or 4. There is no 4, and I don't see the 2. This guy is bad. 1, I look to its left and I see the number 2. Great, this one works. 3, I look to the left and I see 2. This one works. 1, I look to the left and I see 3, but not 2. This one does not work. Finally, this one, I've got a 2. I look to the left and I see the 3, so I am happy. This one works. So it looks to me like lots of permutations satisfy this, but 3 is a very small number to do. If you did it for n equal 4, then you might notice a pattern. You might notice some structure about the guys that work and the guys that don't. So that's another way to develop your intuition for the problem. Here's one final approach. The final approach I recommend is try to construct one. So here I've got the numbers 1 up to 6, okay? And I want to try to construct a permutation that satisfies this property. And I'm just going to start playing around and just, okay, let's start with the number 3, okay? Then what would have to come next? Well, I can't put anything, so I could put the 2 or the 4 next, but not the 1, 5, or 6. Why not? Because, well, the 1, the 5, and the 6 wouldn't satisfy the property. Okay, so I got to put the 2 next. Okay, now what comes next? Well, now I could put the 1 or the 4. Yeah, the 1 or the 4, because that's it. I can't just go and put the 5 or the 6 because they wouldn't satisfy the property. Okay, so maybe I'll put the 4. Okay, now I could put the 1 or the 5. Cool. So maybe I'll put the 1. And now what do I have to do? Well, now I'd have to put the 5. Okay. And now what do I put? Well, now I can put the 6. Cool. Let's try to do it again. See if we develop any more intuition. Let me put the number 6. Okay. What has to come next? Well, it's got to satisfy this property, so it's going to have to be 5. There's no other choice. What's going to come next? Actually, it has to be 4. And next, it has to be 3. Then it has to be 2. And then it has to be 1. Well, that's interesting. So when I start with 6, I don't get many choices. That's telling me that maybe I shouldn't start here. Maybe I should start thinking about it from this end. What could be the last number that I put? Think about it that way. Use the intuition you've developed from your examples that you've done by hand, from your exhausted list of examples, and see if you can find a pattern, and from that, extract a formula.